Hey, hey, ladies and gentlemen, this is Miss Humbert here, and today we're going to be talking about angle relationships. So we're doing Unit 1, Notes 9. So let's start by talking about adjacent angles. So adjacent angles are two angles, so they're adjacent if and only if they have a common side and no interior points in common. So let's just draw something that would look like that, okay? So we're going to have something like this. I'm just going to make it a right angle for fun, and we're going to call this P, Q, and N, and then we're going to have this shooting up, and it's going to be T. So we have two angles here. We have angle P, Q, and T, and then we also have angle T, Q, and N. So those two are adjacent angles because they share this common side of T. Now let's take a look at a linear pair. So a linear pair are two angles that form, so they form a linear pair if and only if adjacent angles and their non-common sides form a straight line. So let's just draw an example of that. So here we're going to have a line. We're going to have an M, and we're going to have an N, and let's just have an X. And then coming out of that, we're going to have this line, which is W. So here I'm going to have angle M, N, W, and angle N, or W, sorry, W, N, X. Now, something important to know. So those two are linear pairs. So if those two are linear pairs, then their sum is going to be equal to 180. Okay, so that's our final answer or not our final answer, but that's what a linear pair is. Okay, so let's go ahead and let's take a look at vertical angles. What makes up a vertical angle? So two angles are vertical angles if and only if they are a non-adjacent angle. So that means they don't share a common side, and it's formed by two intersecting lines. So we have 1, 2, 3, 4. So 1 and 3 are vertical angles. 2 and 4 are vertical angles. And something else that's important to know about vertical angles is that they're congruent to each other. Okay, so vertical angles are always congruent to each other. So we're going to go ahead and write that in as well. Okay. All right, so let's take a look at complementary angles, just so we can kind of get used to some of this vocabulary. So two angles are complementary if and only if the sum of their measures is 90 degrees. We then say that the angles complement each other. Angles are supplementary if and only if the sum of their measures is 180. Okay, so the sum has to be 180. So let's take a look at number 1, for example. So for number 1, we want to find the complement of 25. So what we're going to do is 90 minus 25, and that's going to give us 65. So the complement of 25 is 65 degrees because then it'll add up to 90. So for the supplement, we're going to do 180 minus 25. And when we do that, we get 155. Okay, so then let's take a look at this next one. So we have 87. Okay, so then what we're going to do to get the complement is 90 minus 87. And 90 minus 87 is going to give me 3 degrees. Okay, for the supplement now, we're going to do 180 minus 87, and that's going to give us 93 degrees. Okay, so then taking a look at 134. Well, 134 is bigger than 90 degrees. So since it's bigger than 90 degrees, it can't have a supplement. So that doesn't exist. So I'm just going to write NA. Or sorry, it can't have a complement. So now we can only get the supplement. So we're going to do 180 minus 134. And that's going to be equal to, when we subtract those, 46 degrees. So the supplement then is 46 degrees. Okay? So taking a look at 8, to get the complement of 8, we're going to do 90 minus 8 is equal to 82 degrees. So the complement of that 8-degree angle is 82 degrees. Then to get the supplement, we're going to do 180 minus 8, and that's going to be equal to 172 degrees. So that's going to be a really big angle and a really small angle. Last but not least, the complement or supplement of 90. Well, we can't have something that's 90 degrees have a complement because it would just be one angle. There's nothing to complement it. So there is no complement angle. So the supplement is going to be 180 minus 90, which is going to give us 90 degrees. Okay? So that's that chart for you. So let's take a look at this in actual practice. So first thing it asks us to do is to name a pair of vertical angles. So vertical angles are angles that sit across from each other. So I notice that this angle and this angle are sitting across from each other. So I can say that angle VXW and angle ZXW are vertical angles. So you're going to notice that they're probably going to have the same vertex because of that center there. Okay, so let's take a look. How many pairs of vertical angles are there in this diagram? Well, we have this one. That's one pair. And then we also have this one. That's going to be our second pair. So there's two pairs of vertical angles. So then we need to name two angles that form a linear pair. So a linear pair are angles that are going to make up a line. So I notice that this angle and this angle form a line because you see that there's that straight line there. So I'm going to say angle VXW and angle WXY form a linear pair. But likewise, you also could have said WXY and YXZ. You also could have said YXZ and ZXV. You also could have said ZXV and VXW. All of those. So there's actually 4 different linear pairs in this problem itself. Now let's take a look at some word problems, okay? So it says here that the measure of a degree of an angle is 3 times the measure of its supplement. So remember that supplement means it needs to add up to 180 degrees. So just as a side note, supplement and linear pairs are the same thing. Okay, so let's draw a picture. That always helps me. So we're going to have a linear pair. So it says the measure of an angle is 3 times the measure of its supplement. So I have the measure of the original angle and the measure of the supplement. So now I know since there's supplements that they need to add to 180. So now I'm going to solve this for x. So 3x plus x is going to give me 4x. And that's going to be equal to 180. So then I'm going to divide both sides by 4. Okay. And when I do that, 180 divided by 4 is going to give me 45 degrees. So 45 degrees, that's going to be the measure of that smaller angle right here. Now it asks us to find the measure of both angles. So we need to find the measure of this angle as well, which means we need to take 3 times 45 to get the measure of that angle. And that's going to be 135 degrees. So that's the measure of our 2 angles. Next, let's take a look at this next one. So it says that the measure of one of 2 complementary angles is 6 more than twice the other. So first of all, when I see complementary, I automatically know that here we're talking about 90 degrees. So I'm going to go ahead and draw that right angle for myself. Okay, and I'm going to have 2 angles. So I have one angle that's just going to be x. The other is 6 more, now more means plus, than twice the other angle. Okay, so then all of that's going to add up to 90. So I'm going to have x plus 6 plus 2x is equal to 90 degrees. So now I need to combine my x terms. So x plus 2x is going to give me 3x plus 6 is going to give me 90. Why does it keep doing that? That's so annoying. So now I'm going to subtract 6 from both sides, and I get that 3x is equal to 84. And then I'm going to divide both sides by 3, and here I get that x is equal to 28 degrees. So that's this angle right here is 28 degrees, okay? We still need to get the other one, so I need to plug that x into there. So we're going to have 6 plus 2 times that 28 degrees. So now I'm going to get 6 plus 2 times 28. Now when you add all of that up, you end up getting 62 degrees. You can always check your answers because those two should add up to 90 degrees. Okay? All right, let's take a look at number 6 and number 7. So for this one, given that the measure of angle 2 is 120 degrees and the measure of angle 4 is 2x plus 40, find x. Well, I notice immediately that these are vertical angles, which means I need to add that and set them equal to each other. So since they're vertical angles, I can set them equal to each other. So now I'm just going to go solve this for x. So I'm going to start by subtracting 40 from both sides. So then I'm going to get 2x is equal to 120 minus 40, which is going to give me 80. Divide both sides by 2, and I end up getting that x is equal to 40 degrees. Okay? So now we found that one. So let's take a look at this next one over here. So here it says, given that the measure of angle 1 is equal to 3x plus 10, and then the measure of angle 4 is x minus 30. Oops, angle 4, not angle 3, Miss Humbert. So the measure of angle 4 is x minus 30, not 3. Goodness, struggle. So what I noticed, so first thing I always want to ask myself is how are these two angles related? And they are related by being a linear pair. So that means they add up to 180. So we have 3x plus 10 plus x minus 30 is equal to 180. Okay, so then let's go ahead and combine like terms. So 3x plus x is going to be 4x plus 10 is equal to 180. Sloppy, sloppy writing. So now what I'm going to do is I'm going to subtract. Oops, I forgot this guy right here. Okay, so we have 10 minus 30, which is actually going to give us a negative 20. I like that I keep randomly getting lines there. Negative 20. So we have 4x minus 20 is equal to 180. So now we're going to go ahead and add 20 to both sides. So then I get 4x is equal to 180 plus 20, which is going to give me 200. Divide both sides by 4. And once I do that, I end up getting that x is equal to 50. So that's not what the question asks. It asks us to find the measure of angle 3. Okay, so first thing I need to do in order to find the measure of angle 3 is I need to see if it's related to anything. Well, I notice that angle 3 is sitting across from angle 1. So those two guys are, in fact, vertical angles. So since they're vertical angles, what is the measure of angle 1 is the measure of angle 3. So what I'm going to do is I'm going to take this x and I'm going to plug it in for x there. So I'm going to have 3 times 50 plus 10. Now, when I do that, I end up getting 150 plus 10. So this guy right here is going to be 160. So that is the measure of angle 3 because the measure of angle 3 is the same as angle 1. All right, so let's take a look at number 8. So it says find the measure of angle 5 and measure of angle 6, given that 5 is equal to 3x and 6 is 2x minus 15. Okay, so underneath here, you see that little square in the right hand or in the corner here? That means that it's a right angle, which means that it is 90 degrees. So these two are complements. So we can just add them up. So we have 3x plus 2x minus 15 is equal to 90 degrees, okay? So now I need to combine 3x plus 2x. Well, that's going to be 5x. Minus 15 is equal to 90. So now I'm going to add 15 to both sides. So then I'm going to get 5x is equal to 90 plus 15, and that's going to give me 105. Then I'm going to divide both sides by 5. So now I get that x is equal to 21. So what I need to do is I need to start substituting that in for x so I can get the measure of each of those angles. So I'm going to start by plugging it in. So for the measure of angle 5, the measure of angle 5 is going to be equal to 3 times that 21 that I got for x. So 3 times 21 is going to give me 63. So that's the measure of angle 5 is 63 degrees. Now for the measure of angle 6, okay, I'm going to have 2 times my 21 minus 15. So 2 times 21 is 42 minus 15. So 42 minus 15 is 27 degrees. So those are my two answers, 27 and 63. I can check, and they both add up to 90, so I did that correctly. So let's just last but not least talk about perpendicular lines. So perpendicular lines are two lines, and they're only perpendicular if and only if the lines form right angles. So here's the symbol that we use to indicate perpendicular lines. It kind of looks like an upside down T. Okay, so perpendicular lines form 4 different right angles. Okay, so they're going to form 4 different right angles. Then perpendicular lines intersect to form 4 adjacent angles. So let's go ahead and draw that. Time for lunch. So here's that right angle here. So here we say that L is parallel to M if this is line L and that's line M. Okay, so let's go ahead and let's just take a look at one perpendicular example. Okay, so it gives me that PR and SQ are perpendicular. So that means that this is a right angle and this is a right angle. So first of all, to get Y, it's pretty simple. Okay, all we have to do is do 4y minus 2 is equal to 90 degrees because that entire thing is a right angle. So we're going to go ahead and add 2 to both sides. Come on. I said 2. Oh, it disappeared on me. Hold on one second, guys. We'll just go down to that last problem. Okay, and we're back. So this one's 90. Oops. And this one's 90. So I have 4y minus 2 is equal to 90. So we're going to add 2 to both sides. So then I get 4y is equal to 92. Divide both sides by 4. And I get that y is equal to 23 degrees. Okay, so that's my answer for letter Y. Now we need to take a look at letter X. So for letter X, we're going to do 2x plus 5x. Now notice that these are complementary angles. So when I add them together, they need to equal 90 degrees because they're complements. So 2x plus 5x is 7x plus 6 is equal to 90. So we're going to subtract 6 from both sides, and I get that 7x is equal to 84. Then I'm going to divide both sides by 7, and I get that x is equal to 12 degrees. Okay, so that concludes your note video for today. Thanks for listening.